This is Shreya Sharma. Today we are going to know about solutions. Solution. So first of all, we should know what do we mean by any solution. So basically solutions are homogeneous mixtures of two or more than two components. Now what is homogeneous mixtures? Homogeneous mixtures are those mixtures in which all the components are present in same physical state and they do not get separated by simple physical methods. So we shall consider only binary solutions in the video. Binary solution means the solution consisting of two components only, and the components are termed as solvent and solute. Solvent is the component that is present in the largest quantity, another solute is the component that is present in lesser quantity. Now we will move further to the topic types of solution. There are three types of solution basically. First, solid solutions. First part of solid solution is solid in solid, which means when the solute and solvent both are solid in a solution. For example, alloys. Second part of solid solution is liquid in solid, which means when the solute is liquid but solvent is solid. For example, amalgam of mercury with sodium. As we know, amalgam of mercury is in liquid state and the sodium is in solid state. Third part of solid solution is gas in solid, and it means when the solute is gas and solvent is solid. For example, hydrogen gas in palladium. Second type of solution is liquid solution. First part of liquid solution is solid in liquid, which means when a solute is solid and solvent is liquid. For example, sugar dissolved in water or salt dissolved in water or etc. Second part of it is liquid in liquid. Liquid in liquid means when our solute and solvent both are in liquid state. For example, alcohol in water. Gas in liquid means when solute is in gaseous state but solvent is in liquid state. And the example for it is oxygen dissolved in water. Third type of solution is gaseous solution. And the first part of gaseous solution is solid in gas, which means when solute is in solid state but solvent is in gaseous state. And we can see an example of camphor in nitrogen gas. Second part of it is liquid in gas, when solute is in liquid state but solvent is in gaseous state. For example, chloroform mixed with nitrogen gas. Third part of gaseous solution is gas in gas. When solute and solvent both are in gaseous state, then we termed as gas in gas. An example for such type of solution is oxygen and nitrogen. Now we know what are solutions and types of solutions very well. So it's time to get to know how can we express the concentration of solutions. There are two methods by which we can express it. And what are they? First is qualitative method and other is quantitative method. Qualitatively we can say that the solution is dilute or it is concentrated. But this type of description can add a lot of confusion. So more helpful and better method is quantitative method. There are several ways by which we can describe the concentration of the solution quantitatively. So first way is to by mole fraction. Mole fraction is defined as the ratio of number of moles of that component to the total number of moles of solution. We commonly use symbol for mole fraction is chi, and subscript used on the right hand side of chi denotes the component. Mole fraction unit is very useful in relating some physical properties of solutions, say vapor pressure, with the concentration of the solution, and quite useful in describing the calculations involving gas mixtures. And the formula for mole fraction is chi solute is equals to moles of solute upon total moles of solution, and chi solvent is equals to moles of solvent upon total moles of solution. And we get 1 when we add chi solute and chi solvent. Second one is percentage. Percentage are of three types. First one is mass percentage. It is defined as the mass of solute present in 100 parts by mass of solution. For percent by mass, we use mass of solute upon mass of solution into 100. Concentration described by mass percentage is commonly used in industrial chemical applications. Second is volume percentage. It is defined as the volume of solute is present in per 100 parts by volume of solution. And for it, we use volume of the component upon total volume of solution into 100. Third kind of percentage is mass by volume percentage. It is defined as the mass of solute in gram present in per 100 ml of solution. And the third way by which we can describe the concentration of the solution is parts per million, which is when a solute is present in trace quantities. It is convenient to express concentration in parts per million and is defined as parts per million is equals to number of parts of the component upon total number of parts of all components of the solution into 10 raised to power 6. As in the case of percentage, concentration in parts per million can also be expressed as mass to mass, volume to volume, and mass to volume. Fourth one is molarity. Molarity is defined as the number of moles of solute present in volume of solution in liter. Molarity is equals to moles of solute upon volume of solution in liter. Molarity can be used to calculate the volume of solvent or the amount of solute. Its unit is mole per liter. Fifth one is molality. Molality is defined as the number of moles of solute present in mass of solvent in kg. Molality is equals to moles of solute upon mass of solvent in kg. Concentrations expressed in molality are used when studying properties of solutions related to vapor pressure and temperature changes. Molality is used because its value does not change with changes in temperature. So these are the ways by which we can express the concentration of a solution quantitatively. Each method of expressing concentration of the solution has its own merits and demerits. Mass percentage, parts per million, mole fraction and molality are independent of temperature, whereas molarity is a function of temperature. This is because volume depends on temperature and the mass does not.